All right, so we're looking at polynomials today. At least, like I said, we're starting off with polynomials today. That's 12.2 as far as your homeworks are concerned. So polynomial is an expression that has variables, operations, exponents, etc. So x plus 5 is a polynomial. 15x squared is a polynomial. And 3x cubed plus 7x minus 9 is also a polynomial. In a polynomial, we'll have terms. They're separated by the plus and minus signs. So when I look at 3x cubed plus 7x minus 9, we have three terms.
I'm sorry, Mr. Tucker. Could you go up a little bit? Thank you.
Yep. So 3x cubed is a term, 7x is a term, and negative 9 is also a term. So those are your three terms: positive 3x cubed, positive 7x, and negative 9. All right, can you scroll up? All right, your coefficient is the number in front of the variable. Excuse me. So in 3x cubed, coefficient is 3. In 7x, the coefficient is 7. And with negative 9, coefficient would be considered negative 9. All right, the degree of the term is the exponent on the variable. So looking at 3x cubed, the degree is 3. 7x, the degree is 1. And then for negative 9, the degree is 0. All right, the degree of the polynomial is the largest exponent in the polynomial. So that would be 3/4. All right. The constant is a number that is not attached to a variable. So our constant would be negative 9. Descending order is arranging your terms from largest to smallest according to your exponents. And that's what's normally asked of you. So 5x to the 7th plus 4x to the 6th plus 3x cubed minus 2x minus 8 would be considered writing or being written in descending order. All right, and then ascending order, arranging your terms from smallest to largest according to your exponent. Say again?
Could you go up one, like to descending?
Mm-hmm.
You can go up.
Okay. So ascending order is just doing it in the opposite direction, going from smallest to largest. Like I said, normally you're asked to be put in descending order, but just in case they mention ascending order, then going from smallest to largest according to your exponents. All right, types of polynomials. Monomial is one term. If you just have a single term, to consider a monomial. Binomial is two terms. Remember, your terms are split up by your plus and minus signs. Trinomial is three terms. And just regular polynomials, poly is many. So four more terms, just go ahead and call it just a polynomial. All right. So any questions on that before we go to the next section? As a matter of fact, let me look back. I think adding and subtracting polynomials is still 12.2 for you guys when we switch to that new book. Yep, so this is still 12.2. Still is 12.2, adding and subtracting polynomials. So we're looking at like terms and unlike terms. In order for you to be able to add and subtract your terms, they have to be considered like. And so what we mean by that is that they have to have the same variables, same exponent on your variables, same amount of variables, in each one of your terms. So 3x and 5x are considered like terms. 10x squared minus 17x squared are like terms. They have the same exponent, same variable. Negative 39x squared y, 101x squared y are like terms. And then not having a variable at all, just our regular constants, are considered like terms. Now, unlike terms, if you change anything in the variable or the exponent, they are considered unlike. So you have 5x and 3 here. You would not be able to add or subtract them from each other. 10x squared and 17x, one has the power of 2, the other one doesn't. Then 39x squared y, 101 xy, even though they both have xy, one is missing the power of 2, the other one has it. So they would not be able to be added or subtracted from each other.
I made it. I'm here.
Hey, hey. All right, so let's scroll up. So here are just different variations of what like terms would be. If you had like terms, what you would do. If you didn't have like terms, what the result would be. So 5x and 3x, you just add them together, and that'll be 8x. 5x plus 3, if we're missing the x term right here, that expression is already in lowest terms. You cannot add them together. 5x plus 3y. If one has the x and the other one doesn't, one has x, the other one has y, that's already in lowest terms. You cannot add them together.
One has X and one has Y. Okay.
Right, can't add them together. Then if we have 5x squared and 3x squared, that would be 8x squared. You can add that. But then in the last one, if one has the power of 2 and the other one doesn't, then you will not be able to add them together. That expression is already in lowest terms.
So basically, if it doesn't have the and a like sign, you can't add it together.
You said if it doesn't have, well, it has to have the exact same
Same.
thing in
Okay.
your
The
exponent.
exact same sign or
Mhm.
term. Okay. All right.
All right, questions on that? All right, so let's go ahead and put that to work. So if I have 7x squared y plus 20x squared y, probably could have wrote that one a little more clear, minus 8, then all I would do is add together the terms that have x squared y. So 7x squared y plus 20x squared y gives you 27x squared y.
2x squared y plus. Okay. All right. And then you'll be able to, once you simplify them, then you'll be able to do the actual subtraction of 8, or is that the answer?
Nope, this is the answer right here.
Oh, okay. So actually, you're doing any adding or subtracting.
Say that one more time, the last statement.
So you're not actually adding or subtracting. You're just simplifying the terms together.
Well, we added 20 and 27.
Okay.
20 and 7, excuse me. Mm-hmm.
Okay, so once you do the like terms, you don't do anything else with the minus 8 is what I'm asking.
Right. Mm-mm.
Okay, got it.
Second. All right, so with this next one, you have negative 3x cubed plus 5, I said x, so used to doing x. Negative 3c cubed plus 5c squared minus 7c plus 11 cubed. I say, not used to doing c's. 11c cubed plus 6c squared plus 3. Once again, you're looking at just adding your like terms and what, if there's anything that cannot be added, then you just bring it down. So you're looking at negative 3c cubed plus 11c cubed will give you 8c cubed. 5c squared plus 6c squared will give you 11c squared. Then when you look at negative 7c, there's no like term, so you just bring that down. Same thing with this plus 3, there are no other like terms, so you just bring that down. So that will be your most simplified expression. All right, do another one. Same thing, 4w squared minus 2x plus 3w squared minus 4x squared plus 6x. So when we start talking about like terms, you have 4w squared and 3w squared. That gives you 7w squared. Then you have 2x, negative 2x, and positive 6x, which will give you 4x. And then we have negative 4x squared, which we couldn't add to anything. You just bring that down.
Well, now in math lab, would they mark this wrong just because it's not in order, or is it just?
Well, in this case, since you have two different variables involved, they probably wouldn't be worried about the order. Now, this one, since it was all C's, then they would expect you to do in descending order.
Okay.
Yeah. But they would give you a hint before they would mark it wrong anyway. If they really wanted you to put in descending order, they would tell you, answer is right, but you should put in descending order, something like that. All right. So now when it comes to subtraction, if I have negative 4p to the fourth plus 5p squared minus 3 minus 11p squared plus 4p minus 6, the main difference between subtraction and addition is that the first thing you have to do is distribute that negative. And a lot of people make a mistake there. They'll give the negative just to the 11p squared and forget to give it to the 4p and the minus 6. But you have to give it to each term in the parentheses that follows. All right. Doing that would turn that 11p squared negative, 4p negative, and negative 6 positive. Remember, it changes each one of the signs in the parentheses that follows. All right.
I have a question.
Mm-hmm.
This at the top here, when you distributed 3, do you keep the negative sign or do you turn that into a plus sign? Because you gotta, didn't you say you had to change the signs?
So now
No.
you said at the 3. Now each one of these signs changed.
So we wouldn't do anything to the negative sign itself
Well, that negative sign
outside the
is a
parentheses.
yeah. This negative sign is applied to this 11 and turns it to negative 11.
Okay, I got
Then
it.
it's
I missed
applied,
that.
yeah, and then it changes this to negative 4 and changes this one to a positive 6.
Because in my mind, the negative was already sitting outside the parentheses.
Mm-hmm.
You understand what I'm saying? So we don't do anything with that?
Well, that's what I'm saying. It's applied to each one of these terms, and it changes each one of their signs.
Okay. Well, maybe I'm just seeing it wrong.
You see what I'm saying? Because 11 was positive, but now it's negative. 4 was positive, and now it's negative, and then 6 was negative, and now it's positive. So that's
Oh, I
the
get it.
effect. Yeah, that's the effects of that negative.
So we don't do anything to the actual negative sign outside the parentheses. That's what I'm asking.
No, because once
Okay.
you distribute it, then its application is affected then, and then we're going to add our like terms.
Okay.
Mm-hmm. All right. So negative 4p to the fourth. Nothing could add to that because there's another p to the fourth. So you just bring it down. Then we have 5p squared and negative 11p squared, which gives us negative 6p squared. Negative 4p, there's nothing I could add to that, so I'll just bring that down. And we have negative 3 and positive 6, which gives us a positive 3.
Okay.
All right, any questions on that one before we go to the next one? Make sure we're all right. All right. Ax squared minus 2ab plus 7b squared minus negative 8a squared minus 6ab plus 2b squared. All right, so once again, we have that minus sign sitting in the middle, and we have to distribute to each term. So that turns 8a squared positive, 6ab positive, and then 2b negative, 2b squared negative. Once you've done that, combine your like terms. A squared and 8 squared will be 9 squared. Negative 2ab, positive 6ab will be a positive 4ab. 7b squared, negative 2b squared, positive 5b squared. All right, questions? Any questions?
Is the section number for us 6.42, or do we have another section number for this section?
This is 12.2 still.
12.2, okay.
All right. Questions on add and subtracting your polynomials. All right. So let's look at multiplying your polynomials, and then we will call it a day. This is 12.3. So when we're looking at multiplying our polynomials, the way we should process what we're looking at, let's say if we had 3x to the fourth times 4x squared, you would multiply the 3 times 4, the coefficients that are sitting in front of our variable, and then add your exponents. Remember, that goes back to our exponent rules. And then that result will be 12x to the 6. So that's how you should, even if you don't write it out every single time, you don't necessarily have to, but that's how you should compartmentalize what you're doing. You're going to multiply the numbers that are in front of your variables, then you're going to add your exponents. Looking at the next one, negative 4c to the fifth d.
So we never multiply the exponents, correct? We just add them.
Nope. Well, you do whenever, well, not in this scenario. Remember, we talked about exponent rules. If you're raising a power to a power, if you see this scenario, that's when you multiply your exponents, but not when you just multiply your variables.
Okay.
All right. So negative 4c to the fifth d times 2c squared d cubed e. So the way you compartmentalize it is negative 4 times 2, c to the fifth times c squared, d times d cubed, and then e would just be sitting on the outside. It had no other like variable to multiply it to. And then don't forget, when you don't see anything, just assume you know there's a 1 there for the exponent of d. So negative 4 times 2 is negative 8. C to the fifth times c to the second is c to the seventh. And then d times d cubed is d to the fourth. You add your exponents. All right. Questions? Any questions? All right, next one, 2x times 4x minus 3. So just like you would any other distribution process, if there's a number sitting in front of your parentheses, you go ahead and distribute that to each term. So that's 2x times 4x, 2x times 3. So that would be 8x squared minus 6x. All right. So if I have negative 3a squared, multiplying that times negative 4a squared plus 2a minus 1, I would do that same distribution process. Negative 3a squared times negative 4a squared. So negative 3 times negative 4 is a positive 12. A to the second times a to the second. You add your exponents, that's a to the fourth. Negative 3 times 2 is negative 6. A to the second and a to the first. Add your exponents. That'll be a 3 for your exponent. And then negative 3a squared times negative 1 is just positive 3a squared.
I have a question. I'm a little confused.
Mm-hmm.
Is this where you do what to the powers? Is this when you multiply the powers?
Add them.
Oh, so just like we was doing at the top. Because I'm
Mm-hmm.
trying to figure out, well, where'd you get the 3 from? Oh, because the variable, just count that as 1? I'm trying to
Yep.
figure out.
Yep.
Okay,
You
all
talking
right.
right here? Yep. So that'll be 1.
Yes,
So 2 plus 1 to give you just 3 right here.
3. Okay, all
Mm-hmm.
right.
All right. Anything else before we look at another one? Make sure we're okay. All right, so here we have a binomial distribution. We're multiplying two binomials. So we have x minus 7 times x plus 2. We'll take x times x, which gives us x squared. X times 2 is 2x. Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14. So you take each term in the first parentheses and distribute it to each term in the second parentheses. Some people like to lean on FOIL, first, outer, inner, last. But if you just take each term in the first parentheses, distribute it or multiply it to each term in the second parentheses, you'll come up with the right answer. All right. So then, though, you do have to evaluate and make sure you don't have any like terms. And if you have like terms, you need to go ahead and add them together. So we have 2x plus that's negative 7x, and that gives you negative 5x. So this would be your most simplified expression. All right, questions? Any questions? All right, so here we have a binomial times a trinomial, but the thought process still holds true as to how we will handle the problem. We'll take each term in the numerator, I'm not the numerator, each term in the first parentheses, multiply each term in the second parentheses. So I'm going to first take the y to each term. So y times 3y squared is 3y cubed. Y times y is y squared. Y times negative 5 is negative 5y. Then we take negative 2 to each. And that'll be negative 6y squared. Negative 2 times 3y is negative 6y squared. Negative 2 times y is just negative 2y. And negative 2 times negative 5, positive 10. All right. Combine your like terms. 3y cubed couldn't be combined with anything, but we have y squared and negative 6y squared. That gives us negative 5y squared. Then we have negative 5y, negative 2y would give us negative 7y. And the 10 couldn't be combined with anything. All right, questions? Any questions? All right, erase this. So now we have 2x plus 3 times 2x minus 3. Whenever it's just the signs that are different, those we have plus sign here, minus sign here, plus sign here, minus sign here. They're called conjugates. So whenever that middle sign is different, dealing with your conjugates. Reason why you bring that up is because when you multiply these, doing your binomial distribution, 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. 3 times 2x is 6x, and 3 times negative 3 is 9. It'll be negative 9. So we notice what happens in the middle is that we have a negative 6x and a positive 6x. And that leaves us with 4x squared minus 9. And so whenever you're multiplying conjugates, that will always be the case. Your middle term should cancel for you.
So for this, would you ever just distribute both of them into each other? Since it's a 4. Oh, never mind. I'm tripping.
All right. All right. Anybody else before we go to the next one? We got maybe 1 or 2 more just to make sure we're good.
The little purple box on the side, 1/2 times 1/2 equals 1/4. What is this right there?
Probably somebody asked me a question.
Oh, okay. All right. I just want to make sure we didn't need that in our note.
Yeah. Somebody probably just asked a question from a previous.
Okay.
Down here, that's what it has something to do with. That's why I don't erase stuff too quick. Somebody probably asked, how did I get 1/4? So multiplying these two together, it's 1/2 times 1/2.
Okay.
So here we have 1/2 x plus 6, 1/2 x minus 6. So once again, we have to distribute. And so like your classmate mentioned, that's what this is right here, 1/2 times 1/2 gives you 1/4 x squared. And then I have 1/2 times negative 6. So 1/2 times 6 is just 3. or in other words, half of 6 is 3. Then I had to do 6 times 1/2, once again, is 3. And then 6 times 6, give me that negative 36 in the back.
So let me see. Make sure I got this right. Distribute this to this. And we distribute this 6 this. 6 this.
All right. Then we see our negative 3x and positive 3x cancels in the middle. Leave us with 1/4 x squared minus 36.
Okay, so it's 1 so it's 1/4 x squared minus 36.
All right, any questions? Any questions? All right, if you were to have something like 3w minus 4 squared, what you cannot do is distribute the square and do 3w squared and 4 squared. So what that actually means that you have to expand this out. That's 3w minus 4 times 3w minus 4. So make sure you're careful there. A lot of people make the mistake and try to distribute the square. That's not what that says mathematically. It means you have to multiply 3w minus 4 times itself twice. And so that means we would go ahead with our distribution. 3w times 3w is 9w squared. 3w times 4 give you 12w. 4 times 3, 12w, then 4 times 4, 16. And most definitely don't forget to keep your sign integrity. You know, negative 4 times negative 4, positive 16, but negative 4 times 3, negative 12. Then from there, combine your like terms. In the middle, we have a negative 12 and a negative 12, which is a negative 24. We add them together. And that'll be your answer.
I have a question.
Yep.
Okay, this problem here, why is the two variables that are alike, why they don't cancel out like before?
Before we had a positive and negative. All right. Positive and negative will cancel out, but two of the same signs, you just add them together. So we have two negatives.
Okay.
Here. Yep.
All right. Thank you.
Yep. Not a problem. Good question.
All right, Mom.
All right. Questions before we go to the next one? All right. Next one. Same type of deal. 5x squared plus 2 squared. So the first thing we do is we recognize that, you know, you have to expand that out to 5x squared plus 2 times 5x squared plus 2. Then you do your distribution. 5x squared times 5x squared is 25x to the fourth. 5x squared times 2 is 10x squared. 2 times 5x squared, 10x squared, and then 2 times 2 give you 4. Combine your like terms in the middle. 10x squared plus 10x squared give you 20x squared. All right, any questions? The next one is, should be factoring. Anyway. Okay. All right. So any questions before we close out today? Make sure we're good. We add, subtracted, and multiplied polynomials.
Could you possibly, are you going to post this? Because I need the first half of the notes.
Yep, I can do that before the day is out.
Okay.
All right. And then somebody asked, what's my email? It is vtucker@tcc.edu. Don't forget, if you're trying to set up your test taking, it's jldavis@tcc.edu. All right.
When can we take the test?
As soon as you can, just go ahead and do it. It's on you. Yep.
Like
Yes.
when I click on it in math, it says I need a password.
Yeah, you gotta contact Mr. Davis.
Okay.
Yep, and he'll set it up for you guys to be tested and everything like that. Yep. Yep. As soon as you contact him, he'll contact you back, within a certain amount of time, and then he'll give you instructions on how you guys will go about, getting that test done and proctored and everything like that. Yep. But once we go through the lectures, then it's pretty much on you guys to go ahead and knock it out as soon as possible. You get multiple attempts at it. Really, you have unlimited amount of tries. It's just basically about, do you have unlimited amount of time? You know what I mean? So you go in there and knock it out. You want to at least get a 75 or better. And then, but if you don't, then you get 2 shots automatically without having to consult me. If you try to get another attempt after that second, then you need to, get with me and then let me unlock it and all the stuff like that. But yep, you can knock it out as soon as possible so you can be done with it. Anybody else? Anything else before we close today? All right. So try to stuff out. See if you get stuck. Always feel free to ask questions, whether it be in class or through email. And I'll see you guys next class.
Thank you, sir. Have a nice day.
Thanks. You the same.
All right.